Okay, so we're going to start a little section today on partial fractions. This is going to be run to 3 or 4 lessons, I would think, at least. And partial fractions is fundamentally the reverse of adding / subtracting fractions. So how can we get from this expression to either 2 fractions added together or 3 fractions or 2 fractions subtracted? The reason it's 2 is because I've got a denominator with 2 factors. Okay, so if we've got 6x minus 2 over x minus 3, x plus 1, we're going to let it be identical to something. And the something must have x minus 3 as the minus 3 and x plus 1 as its denominators. Otherwise, when we combine the fractions, we won't get the denominator x minus 3, x plus 1. So we can see straight away that one of these must be x plus 3 and one must be x plus 1. So the real question then is, what goes on the top? Well, at this stage we don't know, so we're going to call it A and B. Right. Now there's 1 or 2 other little things in here that we need to be sure of. This is an identity sign. So it's therefore true for all values of x. And that's going to be important later on as we go through this solution. Okay. So our objective here is to find A and B. Right, so we're going to try and find aim to find A and B. Well, just like when we're solving any kind of equation, the first thing we like to do is to get it on one line. Get on one line, multiply by denominator. And the denominator we're looking at again here is this 3x minus 1, x minus 3 and x plus 1. That's the denominator we need to multiply through by. So when we do that, we get 6x minus 2 is equal to a lots of x minus 3, x plus 1 over x minus 3 plus b lots of x minus 3, x plus 1 over x plus 1. So we can cancel the x minus 3's, cancel the x plus 1's, which leaves us with 6x minus 2 is identical to a lots of x plus 1 plus b lots of x minus 3. Okay, now there are 2 methods for doing this. All right, so method 1 could be described as substitution. Okay, so because this is true for all values of x, we can put in particular values of x. Yeah, so since true for all x, put in, or substitute in, would perhaps be a better word as I've called it substitution. Substitute in particular values of x. So what would a good value of x be to choose? Well, if we look at this, we can eliminate one of our unknowns, A or B, if we choose the right value of x. So to eliminate A, if choose x equals -1, we eliminate the A. So let's do that and see what happens. Let x equal -1. So we get 6 lots of -1 minus 2 is identical to A lots of -1 plus 1, but we know what that's going to be, and I wouldn't bother to write that down in the future, plus B lots of -1 minus 3. So we get -6, take away 2 is -8, -1 plus 1, or -1 plus 1 is 0, so we've got no A's, minus 4B. So that implies B is equal to 2, dividing both sides by -4. Now, how could I eliminate the B? Well, hopefully the answer's obvious. Let x equal 3. So we get 6 lots of 3, take away 2, equals A times 3 plus 1. And when I put 3 into x in the second half, as I say, I wouldn't normally bother to write this down, but plus B lots of 3 take away 3. That's why I've written it in red, because that's going to become 0. So we've now got 18 minus 2 is 16. So we've got 16 is equal to 4A. Therefore, A is equal to 4. And then our answer is, and it's important that we write out the answer because the question said split this into partial fractions, so just finding A and B isn't sufficient. So we've got 6x minus 2 over x plus 1, x minus 3, x plus 1, x minus 3 is identical to, we've got A as 4, so that's 4 over x minus 3 plus 2 over x plus 1 as our final answer. Okay, method 2. Method 2, coefficients. So we start in the same way, exactly the same way as last time. So that was this little section here that we've already written out. I'm not going to write it out again, but where we multiply by the denominator and we end up with 6x minus 2 is identical to A lots of x plus 1 plus B lots of x minus 3. So 6x minus 2 is identical to A lots of, I've forgotten which way it was, A lots of x plus 1 plus B lots of x minus 3. Now, here the logic goes, if true for all values of x, the number of x's, x squared, units, etc., must be the same. So, coefficients of x, the number of x's gives 6, is equal to A plus b. Okay, well that's one equation with two unknowns. Where can we get a second equation from? I'll look at the units. So we get -2 and we've got 1 times a, so that'll be a, and b times -3. So we get -2 is equal to 1a, -3b. Simultaneous equations. So that came from there. Simultaneous equations, we've got the same number of a's, so we could just subtract these quickly. Subtracting. So we're going to get 6 take away -2 is 8. The a's vanish, or a minus a is 0a. B take away 3b is equal to 4b. Implies b equals 2. Is that the same as we got last time? Oh, good news. Okay, if b equals 2, then a must equal 4. Substituting back into either of the equations, it doesn't matter which you choose. But just like last time, we should then write out the answer at the end nice and clearly. And we should get the same, 6x minus 2 over x plus 1, x minus 3, x plus 1, x minus 3 is identical to a, which was 4, over x minus 3 plus b, which was 2, over x plus 1. Hope that makes sense. And we're going to look at a slightly more difficult example in a moment.